Hi, welcome back to Coding with Doc, and on this second session I want to take that same idea of functions and procedures and look at a whole host of new ideas. The idea of global variables, variables that work on every function, and the idea of local variables, ones that work just inside one of those definitions or functions, and how you can allow things to cross them and not cross them. Now, be very careful ultimately with global variables because it can be a bad design. It can kind of work against the idea of functions and procedures altogether. But then I want to build those into some practical examples, like making a calculator, making a menu system that allow you to explore those ideas. Now, in the first session, what we were looking at was the idea of definitions, as you'd call them at GCSE, but really procedures and functions. So procedure are kind of a piece of standalone code that you might put into your overall program that does a particular task, and a function, a particular type of procedure that does a task and then returns a value back into your program. Now, what I want to look at in this session is I want to look at the idea of how you can return the results in, but build them into your program in different ways, just as a kind of a recap to start with. I then want to look at the idea of global variables. I want to pick up the idea about how we iterate in different ways. I want to play again with that menu system idea, and then I want to make a basic text-based calculator. And then once I've done all those examples, in effect doing kind of run examples with you, then what I want to do is to give you some make examples to work your way through. And I might even get a chance to review the makes from the first session as well. So let's begin with the structure as we've always had it. So I'm not going to put in variables at this beginning because I'm not going to use any variables in this that are defined at the top. I'm just going to have definitions, and I'm going to have my main program. And I've created those two headers using the hashtags just so that they're there in the same style you used to from GCSE. And then we go def miles to kilometers, and you'll see that I'm using the same idea as last time round. And we'll do one that carries data in, and what data is being carried in, number of miles is being carried into the program. And then the program is going to be really simple. All it's going to do is return the number of miles times by, and we'll just do 1.6. I know last time round we did it to a lot greater accuracy than that, but we'll just stick at 1.6, which is roughly a mile to a kilometre. Now, you'll see I've picked this deliberately because the def has got data going in, number of miles. The function as a whole is a function because it's got a return, and what's it returning? It's returning the answer to that calculation, whatever the number of miles is. Now what I want to look at specifically is that idea about how you print that, how you get that to come out, etc., etc. So what I want to do is go print. Now, the idea of a good program is to minimize the number of lines and to think about how you're calling things. So I'm going to say print. Now what I want to print is the answer to miles to kilometers. But to do miles to kilometers, I need to know the number of miles, and I haven't done an input statement that asks for the number of miles. I could, of course, go here and just go number of miles equals an int input that says enter the distance in miles, like that, like so, double bracket. And then I could say there it's number of miles using number miles or number of miles. I accidentally called it number of miles there, but I've consistently called it no miles there and number of miles here. That will work fine. It doesn't have to have the same variable name in both. So print that, but rather than end the print statement, put the word kilometers after it, which is one of those tidy up things that we weren't doing last time round. So when I run that, obviously it wants to save it, and I'm just going to call it example again and drop it onto my desktop. Now, when I do that and it says enter the number of miles and I put in 30, it says 48 kilometers. Now, you'd think that's the smallest amount you could do. But here, number of miles is this. So there's nothing stopping me going, instead of number of miles, let's put an input statement in my print statement as another command. Now you see how that's taken one command and in effect like a Russian doll wrapped it inside another command. Now if I run that, it says enter the distance in miles and I put 30 and it puts 48 exactly the same way. And I've reduced my functional code there to 3 lines. And you'll see how it's taking in this input, doesn't even have to go in now as a variable, so you never see it being called number of miles, it's just do the input statement. The input statement is a number that's going in, which as far as the definition is called number of miles, but as far as the main program is concerned, is just an input statement. And then it calculates it and returns that to the main program. So it's going in and out of the main program in terms of the data itself. Now, what I now want to do is play with another idea that some students really like. The danger is sometimes they can like it too much and you can end up with code that very heavily relies on these things, and it kind of sort of defeats the idea of a definition. So this is the idea of a global variable. So we're going to look at that idea of a global variable. Now, we're going to go username equals quote quote. And what I'm going to do at the top is just put one of those hashtags in that says global variables. Variables that are going to work everywhere in the program. Not like number of miles did previously, where it just number miles worked previously. It just worked inside the definition. This is username, and it's going to work everywhere across all the things. So what I could do is create a command that says definition ask name, like so. And in that I can say make a global copy of user name. So in effect, make that variable apply throughout the whole program, and then go username equals what is your username. Now, dead simple definition, etc. Now, in terms then of the program itself, I can do, say, another definition that says tell user we won't carry any data in, and we simply go print, and then we're going to run username, and we're going to say is a lovely name. Do you mind if I use it on my child? So the person types in a name, Andrew, James, Bob, and it goes, that's a lovely name. Do you mind if I use it for my child? On my child sounds a bit weird. Yeah, for my child. Now, you could create a separate main definition here that runs both of these. But if in terms of my main program, I say run ask name and then run tell user, that should work across both. If I run that and it says, oh, let's do an input. it says, what's your username? And I say, James. And it says, James is a lovely name. Do you mind if I use it on my child? Now, note, if I took that out and run it, and I put in Andrew, it doesn't allow the variable to be used elsewhere. So to make a variable work in another place, you've got to, I thought I was copying and pasting the right command and then I didn't copy and paste it. You've got to put in this idea of a global username. And once you've put that in, it allows that check to occur, that cross-reference to occur to see if that would work. Now, what I want you to do next is to take that idea and I want you to create a challenge for yourself where you make a program that says, what's your name? And then if your name is, and pick 3 kids in your class and do 3 different comments based on those people, based on those names, and then close it in terms of the main program. So really you're wanting a kind of an ask name. You can keep that in one variable where it asks the person's name, but then you're changing my tell user. So you're changing that to be about 3 people in your group or 3 names of people that you know, and you are making a different comment based on those 3 names. Now let's see if you can do that using that structure. So that's just investigate. So you've known that on procedures or functions they can take data in. It calls data in the brackets as the name goes there. And it can return data out. That's what makes it a function, when it returns data out at the bottom of the program. What I want to do is to interweave all those ideas, functions, procedures, global variables, and look at making a basic menu system at this point in Calculator. Well, let's work through that example. So I asked for a definition that asks them the name, which we've got there. There's a simple definition that asks them to put the name in. You could put what is your username, or buy to quit. Yeah, so I'm just adding a little feature there that we didn't really talk about. Now, then I want to do an option that says some sort of comment based on their username. So if username is the same as empty, now let's set username at the top to empty. In fact, let's do it like this. Let's do if username is empty, and then let's create a variable at the top which we'll call empty, and we'll leave that one blank. So if username is the same as empty, then we'll put print. How rude. You didn't tell me your name. Exclamation mark. So that's straightforward. Elif username equals Harry. Then we'll put print. I hope you are not the one that is a well-known striker. Then Elif username equals Virgil. and then a print that says, do you play in defence by any chance? And then last name, Elif, username equals Sadio, print amazing winger. Now, oh, you'll notice there that's not gone orange because I left a T on the end of it. So we'll do Elif, so one more, Elif, username. Now, I've just noticed I've put equals rather than equals equals. It's got to be is the same as, not it is. So if the username equals by, then what we want to do is print thank you and have a nice day. Let's go full American on it. And then last of all, let's do a final else that works with all of them. Else, there we go. And let's put print username is a lovely name. Now, when it comes to running that, we could have, of course, put all those Elifs inside tell user and there would have been no problem with doing that. I want to just tweak it up a little bit. I'm going to put like a main program here. And in this main program, I'm going to say, while username is not the same as by. Now remember, because it's a global variable, it will see it in this option. And then what we want it to do, so while it's not the same as user, we want it to run ask name. And then here we just run main. And that then should work. So when I run that, it says enter your username and I put in Andrew. Andrew's a lovely name. And it laps round Harry. Are you a well-known striker? Virgil. Do you play in defence? Sadio. If I spelled it right. Amazing winger. And then if I put by, thank you, have a nice day, and it quits. Now you see, that's quite a nice little way of hanging the program together in separate things. Now, of course, there was nothing wrong with taking that, dropping something like that in the main program, or just ask name itself in the main program, and saying, while username is not the same as by, and then what did we have this one called originally? Let's call it action. I can't remember what it was called. And then doing all of that in the action and saying ask name and then run action. Now, that's probably what some of you started off with. And if you put in Andrew, Andrew's a lovely name, Harry, Harry's not the one, Virgil, etc., etc. So that's probably, based on the example I left you with, the more accurate version of what most of you did. But I wanted to show you that alternative way as well, that you could have put things in the first, you could have created a main program, because programming is about different ways of coming at things and thinking laterally and trying to do all those different ways of doing things. So now the next thing I want to do with you, let's just take all those out, is this idea of building a basic menu system and then letting that menu system kind of run through, having a play with it, seeing how we can do it, etc., etc. And we'll probably stick with the idea of having some sort of global variables, but we'll see. So I'm going to start off with a definition. And on this first definition, I'm going to call this definition menu. And inside menu, I'm going to create a little local variable called user choice. And I'm going to set that to being a 1. And then I'm going to go part 1 equals a star times 20. And then I'm going to put in a \n. Now, the \n, let's put a plus, so it adds it to the end of 20 stars. \n will drop a line, and then we'll go plus press \n to drop another line, 1 to add a new user. So that's giving me now, instead of doing a separate print statements, I'm in effect wrapping them all into the same one. New line, and then this time around we're going to go 2. Now, let's just show you that these don't need to be together either. So I could go part 2 is, and then just go to see the customer balance. So you can break it up, and then a /n again, and then go 3 to adjust the balance. Yeah, cash pointy, cash pointy style. And then keeping that theme of multiple ones, you could do drop another line after that balance one. You don't have to put it with the same one. Let's do a 4. I put a dot after the 3, but not the 1 and the 2. And I'm just thinking for consistency, I should put those dots in. I think the dot looks nice, that's why I didn't take it out on the 3. And we'll do 4 to quit. And then we'll drop another new line in there. So we've made it do a new line. And then we'll go plus star times by 20, just like we had at the beginning. We'll have it now at the end. Plus a /n, which drops a new line again. Now, I've done all of that, and then I can say message equals part 1 plus part 2 plus part 3, and that's going to stitch all them together, obviously. Now, if then we could either choose here between making a main program or just putting it all straight into a main program. I'm going to do a main definition just so you get the idea of doing a main definition, then just running main. And we'll say user choice. Let's call that full user choice. User choice equals an input. Now, we're doing an input, but I'm not going to leave it as an input. I'm going to say run as your input menu. A run menu. Now, we're then going to do if user choice equals 1, print let's add a customer. And then do an elif user choice. Did that same mistake I did before. User choice is a 2. Then we want it to print Do you have an ID for the balance? Elif, user choice. And some of you are going to be screaming at me because I've just noticed I've done it again. I've missed those double equal signs out. Yeah, see, the best of us can make these errors. Not that I'm claiming to be the best. 3, you're then putting in an option, and this one is to adjust the balance. And there you might say print how much are you paying in today. Now you see I'm just demonstrating the fact it runs, so you've got the idea and you can see all that. And then Elif, user choice is a 4, which of course is to quit. We're then going to put a relatively straightforward one that says something like print goodbye. Now, what we haven't done is wrapped all that in any kind of program. So now we could do, well, we haven't made user choice global as well. So we're going to need to make user choice into a global variable so that it'll run through the various ones. So if we simply run main here, watch what happens. Well, what do you think is going to happen? So we run it. I bet you didn't spot that one because I'd not spotted that one, the missing colon at the end of that line. So now it's going function menu at, and it's picking up the error message inside that original user choice. So what we could do here is go while user choice is not equal to 4, run main. And there it's running user choice is an input. And what input is it? It is in fact, let's make the input message. So it does the whole of message there. So now we'll create, so you see now how it's struggling because user choice is stuck inside a variable. So we'll say user choice starts as 1, and then we'll say global user choice. Now that should ride around that problem of it not being defined and it not recognizing user choice. Wrong way around. So we've done that. You'll notice I'm now having to put menu before user choice because it wasn't running menu, so it wasn't working. And there it throws it up and says, what do I want to do? And if I choose 1, it says let's add a customer. 2, do you have an ID? 3, how much you paid in today? 4, quit. Now I want to look specifically with you at this idea of global variables and watch how they move through 2 different functions or procedures and see how they interact with one another. So far on this particular lesson, what we've looked at is we've looked at this idea of functions and calls within functions. We've then looked at global variables and how global variables can be used, how that works in terms of looping, how that works in terms of making menu systems and different commands around menu systems. And now really what I want to do is stitch all those ideas together, make a basic calculator kind of program, do a lot of kind of run and investigate type examples so you can follow me and you can play along with it and you can do it and pause the video, make your own, pause the video, make your own, and then move from that to doing one where you are adding the final set of features into that calculator yourself. So as always, we'll begin with a basic structure. We'll start with imports, although I'm not intending to have any imports. We'll start with variables, although I'm not intending to make any of these global variables. And then we'll have some definitions. And we'll just leave that. We'll have a few definitions, and then we'll have our main program. So the first definition I want to make is a definition for a banner, which is going to be the introduction to my program. Now, you could do a banner where you do it all in the same one, or we could do a banner where we have a second one, which is a definition that kind of does text to the banner, or text on banner. So we'll call it text on banner. So, as I say, you could merge this into one if you feel particularly confident as we're going along, and I could experiment with doing that, or you could have it putting the text on the banner. And we'll call this one banner there for the banner text that's going to go through from this one into this one. So banner will get called inside text on banner. So the two are going to kind of work together. So we'll start with a temporary string. And you'll notice I don't call it string because string's a command word. So we call it temporary string. So it's an empty string. And then we'll call it character fun. So a letter that we're going to put in between them. Now you can use a hashtag here. You could use an @ sign. You can use any of the kind of more unusual characters on the keyboard. I'm going to use a star because we've used them up till now a few times. And I'm going to then say for a letter in the banner, now the banner is going to come through from this other program, what we want it to do is change temporary string. And temporary string is going to become whatever's in temporary string, but then we're going to add to it a bunch of things. We're going to add to it a fun character, the star, and then we're going to add to it the letter it's picked up. So in effect, temporary string will become star and whatever we've put in banner, star and whatever we've put in banner, star and whatever we've put in banner, and it's going through banner a letter at a time, making it look a little bit more interesting, as it were. And then at the end of this, we want to return, and what do we want to return? We want to return that temporary string that it's modeled. So that's done that first bit. Put text on the banner, you're going print. Now we need to run that banner command. And now the banner command is expecting text to go into it. So you could put text in. Now you could make this a variable that says what text do you want to put in. I'm just going to put in something like a simple calculator. Now, it strikes me that I actually might want that in uppercase, so I can do that by going .upper. If I typed it in upper in the first place, I wouldn't need to bother doing that. So then that's made that first command that's doing that banner print, and you'll notice two brackets at the end. It looks like there's a lot of brackets there at the end. There's two brackets around the upper, there's two brackets there going in, and that's running that through. And then what I'm going to then do is go print and put a basic command in like welcome to the calculator. I could do a /n at this stage, but I'm not going to do that, just to drop a line. And then I'm going to say choice equals an input, and then I can do a long input here. So I'm going to put type and then do my /n's 1 to add, /n 2 to subtract. Now, clearly, when I stop in a few minutes and ask you to carry on, you're going to be able to do 3 to multiply, 4 to divide, 5 to do whatever you're doing, and then do 0 to quit. So that's created that basic input, and then what we want to do then is return choice. Now, in effect, if we return it as an integer, it's going to convert it into one of those numbers. But rather than expect it as one of those numbers where it might crash, we can return it as a number and just check it does go into a number. Now, having done those, we're now into the business of creating our numbers themselves. So if I do a definition, we call this one get numbers. So just a straightforward definition that gets numbers, and we'll call it number 1 is a float, and it's a float input, and we say please enter the first number, because of course we can summon this whether we're doing adding or dividing. So please enter the first number, and then we'll have number 2 as a float input where we're saying exactly the same, but this time around please enter the second number. So you can see how this is very rapidly coming together, and how I will have finished this little bit of a demo shortly. Now, what we're going to then want to return is we're going to want to return number 1 and number 2, and that gives you that set of numbers that are coming through. Now, we can then do a definition that does the addition. Now remember, it will have returned the numbers by this point, so what we'll want to do there is print A plus B, or number 1 plus number 2. Let's call it A plus B at this stage, yeah? Because as we send them in, we can send them in as A and B. So we can send in number 1 and number 2 as A and B into that particular definition. And then I'll do a definition for subtracting. And we'll, again, likewise send in A and B, which will be number 1 and number 2. But this time around, it's just going to print A minus B, and it's going to subtract the pair of them from one another. So then we end up in the main program. Now, as I say, this is not a huge program at this stage. And what we've got to do there is go while choice in range 1, 3. So between 1 and 2. So 1 for addition, 2 for subtraction. It knocks out the 0 for quit, stops executing that while loop when it's 0 for quit, and in effect quits the program. So you can then do your while choice, and then you can say the first thing we want to do is run text on banner. And that'll run that simple calculator, what do you want to do option. And then we're going to say if choice is the same as a 1, it's done 1, we want to do A, B, so gather those numbers A and B, using get numbers. So use that get numbers that returns number 1 and number 2, and put number 1 in A and number 2 in B. So AB is get numbers, and get numbers has that return of 2 variables coming out of get numbers. And then having done that, you want it to do addition with A and B. And if the choice is otherwise, if the choice is 2, you want to do exactly the same thing. AB is get numbers, but this time round you want to do subtraction on A and B. And having got to that point, the last thing you'll do then is do a print, which is what it'll do when it quits on that final thing that just says quitting, and it just closes the program. Now, I want you to play with that, run that, test that, check that that's working, and having done all that, I then want you to expand it. Make it so that it's got multiplication, make it so that it's got division, make it so you've thought about maybe even floor division where it tells you remainder. Now let's look at the answer to that calculator example. Well, I've made that calculator, and you can see that I've changed the odd variable names. So things like I've called on fancy, it text in. So you're clear that it's the Python calculator words that are going in there. And then we've got this, as we've said before, this double return. I had to watch the brackets on the end of things, the brackets there and the brackets there. Obviously, you need the same amount of brackets to close a line as you have that you're opening a line. And then that gives us that kind of working set of programs. So if I wanted to add some extra features here, I would be adding them in here. So I can just go straightforwardly a /n, and then I can do 3 multiplication, or to multiply. And then I can do a /n and then a 4 to divide. You can press return like that and it'll keep it inside the same print command as if it's one that's there already. And you've got another /n 5 to exponent. And we'll leave it at that. So on this, we've got to change this one to living up to 6. And then we're going to want to do some copies of these definitions. So the multiplication, well, that's going to be very easy. That's just going to be A times by B. Then the division is going to be A/B. We'll do a straight division. Or we could do it and we could go print A//B, comma, remainder A percentage B. And so percentage gives us the remainder, and // gives us the floor division. And then last one, we've got exponent AB, and go A ** to the power of, and then it'll do that one. So these ones, then you can simply copy that and throw those in, and you can go elif, elif, elif. So there, we'll change that one to being a 3, that one to being a 4, this one to being a 5. Each of them are running get nums. This is running exponent. This is running division. And this one's running multiplication. Now you can see there I've done that. So if we were to run that just to test that that's working, got a literal on one of these lines. It's really not liking me wrapping that text around like that. It should do, but it isn't. So let's leave it on the same line, and then it'll be quiet. So now it gives us this much broader array of things. We know 1 and 2 are working, so let's do 3. What's the first number? 2 times by 3, 6. Good, that's working. 4. What do we want to do? 24 divided by 6. It's 4 and 4 remainder 0. Let's try it again, and let's do this time 26 divided by 6. And there you get 4.33, or 4 remainder 2, which is quite nice. And then you go 5, let's have 3 to the power of 3, and we get 27. So you can see all those are working. Press 0 to quit, and that takes us to the end of this first session, this first book, which is looking at procedures and functions. So really this has wrapped up that idea of procedures and functions, and now we'll move on to new topics at this advanced level.